Welcome. This is a joint talk. We're going to cover different ways of understanding a large code base, especially when you're unfamiliar and new to it. This is something you'll have across your careers, not just when you're starting out, but also when you move team or move company. So to just give you some various tips and tricks. So
Yeah, and feel free to raise your hand, ask questions. It's going to be an interactive session. And again, thank you to the organizers for having us again this year. All right, so here's our information. If you need to get in contact with me and Chris, we'll flash it at the end, and slides will be available as well shortly after. You've read the abstract, hopefully, you know what you're getting into. And introductions.
Yeah. So I'm Chris Croft-White. I work for Undo, so one of the sponsors here. I've been sort of supporting new customers at Undo for the last 5 years, but my background has been over 20 years in pre-sales. So this is pre-sales engineering. I work with meeting new customers, understanding their environment, their tool base, their code base, and how we can integrate with them. So that's where I'm coming from this. So primarily working with time travel debugging from Undo. It's a wonderful tool. Everyone should be using it. And if you're not, really question yourself. But yeah, also could do with some more sleep. I think I managed 4 hours last night, which is currently a record for this week. That's as in the most, not the least. So we'll see how we go.
And I'm Mike. Primarily, I'm a teaching faculty. Feel free to reach out to me if you're interested in teaching. Otherwise, I do contract stuff and computer graphics. That's sort of my domain. And you could read a little bit more about me otherwise. So we do want to get started off with this talk on understanding large code bases with a question. And folks could just shout this out or raise their hand, but what's the largest code base you've worked on? You know, that you're allowed to say in terms of
25,000 lines.
25,000. That's a good size, good healthy size, yeah. 2 million, okay. 5 million range, yeah.
Is this an auction?
Yeah, 10 million. So some pretty good sizes here. I mean, I've heard sizes in megabytes, lines of code. And, you know, just to, get some follow-ups on this, did any of your code bases get smaller during this time? Significantly smaller? Not usually. I see some folks smiling. Usually our code tends to grow a little bit here. Did the code base become less complex over time as it grew? Maybe parts of it. Some folks are going back and forth, but oftentimes more code or as things grow, maybe there's more complexity. Was that code base well documented? Okay, most folks are saying no. Never. Okay. And how many of you just said at some point, hey, let's just scrap the project and rebuild it from scratch? Yeah. Now, did anybody successfully sell their manager on this? Probably not, right? This has to deal with, the business side of things too sometimes. So not always as easy to do. So, we have to wrestle with this code base somehow. So again, just scale as far as code bases go, right? We get the point that code bases can get quite large. I mean, I found this figure, it's a few years old now, various estimates, operating systems are in the millions, even an app for, say, your iPhone or Android, 30, 40,000 lines of code. I mean, that's a good size. Big enough you can't keep things that are in tens of thousands of lines of code all in your head. Right? So this starts to become quite challenging. But again, you can see the scale, and as some folks mentioned, millions. I've heard of mono repos that are in the billions of lines of code, depending on how you're counting auto-generated stuff and so on. And just for reference, pick your favorite book on your bookshelf, that has the most pages. Here's an example of one, million lines of code is about 18,000 pieces of text. That's 14 of these guys. So again, just making the point that you can't keep all the code base in your head usually, and even all the details of the architecture and so on.
So, I guess the initial question is, what makes a code base hard to understand? It's lines of code is one factor, but it's not the only thing. It's not the sheer volume. What other things can people think of that make it hard to get your head around?
The organic growth of code base.
Yeah, the complexity, especially as it evolves, and when you've got old legacy code, it can definitely be a challenge.
Lack of design, when things get cobbled together for wider design.
Oh, yeah. A lack of overall design overview of what it was looking to be. Yes, yeah, as things get more complex and people just add on a whole new extra way of doing things rather than trying to refactor and design things.
Bad engineers.
None of which are here, of course.
Yeah.
Or changing ownership.
Yeah. Yep, lack of testing. All of these things. Sorry, one more.
Yeah, we have lava codes that are like, there was an anti-pattern from the anti-pattern of like code that's not really used anymore, but still.
Yeah, exactly. There's a whole load of complexity just hiding in the code for various reasons. And so when you're sort of getting started, unfortunately for most of you, the code isn't going to be as simple as that on the right. But you've got to understand, what's the logical control flows, what's the data flows, how is this code orchestrated, how is it stuck together? I mean, we're almost all working with multi-threaded at least codes. I mean, yes, you may be using coroutines, fibers, and other ways of doing it, but we're working in a parallel world these days. It's very rare we have single-threaded. I know some of the finance guys are still doing very single-threaded high-frequency trading focuses, but generally you've got the threads you've got to deal with, and you've got to try and understand, how do I get to grip with this code? What's the way it flows? What's the way this interacts? What part of this million lines of code interacts with what other part of this million lines of code as we're doing it? So, we've got to look at the flow, where the state changes, we talk here about, is the name of the function reflective about what it does? So actually, how helpful is the code base? Here in this example, we've got some variables named y and x. I hope this is a coordinate system. Otherwise, it's unhelpful variable names. We've got to talk about self-documenting code. Has anyone actually successfully had self-documenting code that people can pick up and understand immediately? Well done. Congratulations. Most of the time it starts as a good idea, but doesn't actually persist as things grow. Because too many corner cases come in, people are too busy trying to just hack things to make it work, and then you end up with nasty little gotchas which are hiding out in the weeds. So yeah, that's that. Pure scale, as Mike already said, that just the lines of code is one way of imagining it, but it's not just lines of code. And we'll see some of the mixtures we see later, but even in just the C++ code, the different standards being used across different libraries and different components can make it really difficult to keep track. And some of the features you're using in one module, you can't use in another just because they haven't been built to the same way. So these are various sort of design patterns and architecture you need to be able to understand from your source code. And yes, the wonderful visualization on the right, imagine that's sort of how it feels sometimes when you're trying to find your way through code and understand what's going on. But also human factors. Conway's law is actually something that Mike introduced me to, but this is the idea that the code often reflects the people. I don't think this is actually that surprising. You think about psychology, but it's not just the individual, but also the team makeup. So if you're broken into lots of small little teams, you tend to find code which is broken up into lots of small little components that are all working together. So microservice type code bases are quite likely to be developed by a lot of small little teams, as opposed to sort of more monolithic applications. So the team structure can, in fact, and that's not just team structure locally. With a lot of companies now, we're talking about the global development team. So you've got different countries, different time zones, different groups. It can be very difficult to understand what someone who's a colleague of yours, but just happens to be in a different country with a different organizational structure is doing, especially when companies are acquiring others. So you end up with disjoint organization structures inside the one company.
Yeah, I was just gonna say, if you have a reorg or something, what happens to that structure? Hopefully it reflects what you had. Sometimes it made sense. Divide up a graphics team and a sound team, but not always.
Yeah, and definitely the bottom bullet point there, the undocumented code that only the senior engineer, who is off skiing for a week in Mexico, which is always a challenge to ski in Mexico, but for whatever reason, they suddenly are then out ill after they break their leg for 2 weeks, and now you can't fix your bugs. You need to try and make sure your code base is better organized and in a better shape than this. So I think, yeah.
Yeah, so, why am I talking about this topic? Let's see who read the abstract. And why are folks interested in this topic here? I mean, have folks gone through, yeah, because it's really difficult, right? It is a skill to some extent that we have to learn.
More than all.
So it's the norm to jump in, right? You're usually not on a green field starting from scratch project. Yeah.
Well, that's,
Yeah, so can't just scrape the old stuff. There's been famous instances of this, right? Banks and so on running old languages that we don't even train in school, let's say, of legacy code bases. So yeah, this is all good stuff. I think you hit the nail on the head. And again, it's kind of from the abstract. When I started off as a software engineer, and I think we can all relate to this, I just remember having that feeling of, ooh, this is difficult. How do I start? As the intern or somebody doing a new project in consulting to figure out what's going on. And true story, I've been on projects that I've started even today where they're using old, SVN, CVS, old things that it's like, I kind of remember and still use it. Yeah. Yep.
And but we also have the SVN because the QA likes it.
Yeah. Different people like different things. So
Okay, just a show of hands. Who's still using CVS?
one hand, I see.
Okay, yeah. So we go back a long way with these architectures, and it's all confusing and different, and everyone's got to learn a new one.
Yeah. And I have found memories of learning these different tech tools, but tech stacks change here. So again, you kind of get the idea here. And I think especially early on in my career, it was a little bit too embarrassing on the first week to raise my hand to the manager and say, hey, I don't really know what's going on here, right? You want to feel like you were the right person hired for the job. So part of this talk, many of these tools you might know, but just to set the stage, it's also for the senior engineers in here to say, how can you welcome a new engineer? What tools can you give them? How can you walk them through a project here? The other thing, and I get to blame myself a little bit, but we often don't in university teach folks to read a 1,000,000-line code base. I mean, some folks are doing a great job at that. I'm trying to do better. That's why I come to conferences like this to talk with you folks. But in schools, I don't want to blame schools because they teach a lot of wonderful skills, but this is just one of the ones I want to elevate on the radar a little bit of, let's really prepare graduates, to be able to have this skill of reading a large project. I can ask this question here. How many folks, here's another way to think of it. How many folks have written 10 books in their life? Okay. Now, last time I asked this, somebody did raise their hand. How many folks have read at least 10 books in their life? Everybody, right? So, right, kind of the same thing with code as reading when we're learning a new language or just reading for fun, right? We read a lot more than we end up writing. So this is something I've stolen from Titus Winters, who's given a lot of talks, who has ingrained this to me in teaching that students should be reading code, right? We should be learning from each other, and it's a good throughput. So this is a skill that we need to learn, how to read large code bases. Now, as far as understanding code goes, there's a lot of different ways to mean understanding. Sometimes we mean the performance, sometimes we mean safety, or some other metric of the software. Today really is about understanding code flow, how to dive in, how to just understand how some system is working. But again, there are other metrics and other follow-on talks from this that we want to emphasize. But some of the tools we're going to show today you could use for evaluating performance and safety and so on. So we're going to focus on three sort of categories today: understanding code flow, scale, and the human factors that go into code bases. So with that said.
Yep. So we've decided to use a sort of hopefully accessible application that some people will be familiar with. This is the original Transport Tycoon, but we'll work with Open Transport Tycoon Deluxe, just because open source code bases do make these things a lot easier to work with and explore. So as I say, this is a video game. It's a really nice game, and there's a lot of engineers who have come across it, have known hours disappear into this, and they will again and again. But it is fairly accessible what's going on. So some of the ideas we'll try to demonstrate, we'll talk through this in the game context, might make a bit more sense. If you're wanting to follow along at home, say you can download the source and build it and get it. Obviously, this is an open source version. The actual original game, I think, was released in 1992. So Chris High Microprose. It was actually the first computer game I personally bought as a Christmas present. Well, it was bought for me as a Christmas present, but it's my first game, and I absolutely love the game, and I still play it occasionally now. But that was the original thing. The open source project started, I believe, around about 2000, but it's been going now for 25 years. So when it comes to legacy code bases, this is going to have a lot of the problems. You've got many contributors. It's long-lived code. Lots of new features and things have been added. And being a game, everyone is really keen to add new features so they can do new cool things in the game. Nobody's looking to refactor and tidy up and make the code just more maintainable and resilient. So this is a lovely, spaghetti nest of difficulties to pick up and try and pick your way through. But as such, a good project for learning. And this is something that, as Mike says, while you're learning to develop software engineering in universities, things like this can be good ways to pick that up. So we've got a tool here. This is a count lines of code tool. As you can see, there's a huge selection of different languages in the files here. In total, we've got what's that? Just over 300,000 C, C++ lines of code in the C and the header files. So this is a substantial size project. This is definitely something which is comparable to real-world applications you might be working on, real-world projects. So I think we can agree this is a large code base, and given the over 20 years of history, it's a substantial size with a lot of legacy. This is going to be very comparable to the sort of thing you do at home. So the good news is you don't need to learn on these really boring applications. You can pick something fun that can inspire you and find different ways to help you pick your way through the code.
Yeah, and Chris, I was going to say, just through that
Oh, sorry.
diagram, it's kind of interesting to see all these different languages used, which is another kind of thing of complexity. I've been wondering, where does Objective C++ come in? Is there an app in here? Well, I don't know.
Yeah. That's all sorts of options. I suspect that some of this may be misclassified or just based on bad MIME typing, but definitely you can see that there is a lot of complexity in this code base, and it's not just the C, C++. There's a lot of supporting files, metadata, and things going on. There's not a huge amount of documentation in there. Was that 5 HTML files? Yes, there's 3,000 lines of HTML, but that's not necessarily going to give you great documentation.
Yeah, and the D there is misleading. I thought it was one of my favorite languages, but that's actually from CMake. So 93,000 lines of something there.
Okay.
All right, so let's start with just understanding code flow, right? We should actually jump in, show some tools here, and see what's going on. So, the very first thing that I like to do is run a project here, right? And actually figure out, where do we start, what's going on, how do we, build this system here. And it's not necessarily trivial to build software either. So that's another sort of issue, another thing for if you're a senior manager to keep on your mind if you're going to document some process. Again, I have the embarrassing story of it taking me days to get software projects that I've worked on to get it just compiled and built and my IDE set up and all these sorts of things here. So, even before we build, we might want to get an idea of where does the program start? Where are the entry points? So one thing we can actually do is grep for them, right? We can find out where usually the main function starts. So I want to go ahead and just show this here. I'll do a little bit of demoing here. So I've got a virtual machine set up here. And here's our open Transport Tycoon source. Let's make it just a little bit bigger for you folks here. Folks in the back, how are you doing with seeing this? All right, great. So again, grep is our search tool. Today we're going to be using a lot of Linux-based tools here, but you'll have other tools like find and other advanced search tools that you can use. But let's just grep for the main here. I'm going to do something like this with a parenthesis here, do a case-insensitive and recursive search, and I'm in the source directory here. And I want to look through all the directories here. And I find a lot of different mains here. So let's try to filter that a little bit here. I'm going to use NL here, just to give you the full command. There it is. There we go. Let's size it to our screen. About 33 main functions here. And again, I can play around with, putting the parentheses somewhere else and get different results here, depending on how our code is formatted. But already there's a few interesting observations perhaps here. If you're familiar with the graphics domain, I've got this thing called a shader, which is a graphics program. Okay, so there's some mains there. If I kind of search around, there's some third-party libraries here. Catch, a famous framework here, I've heard. I've got this thing here, Open TTD Transport Tycoon Deluxe main. Okay, that's kind of interesting. And again, if I scroll around here, I'll eventually find maybe a Unix main, maybe there's a Windows main, and so on and so forth. So already we could kind of find some interesting things about the code and this tool grep. Now, of course, if I keep scrolling through this, you'll find some other interesting things as far as the entry points go. You'll find things like, this is a C declaration and other things that might, bring up some interesting questions here. And the other thing I want to point out is sometimes you'll find main or these strings generated in other files, sometimes in the binary. So you can ignore the binary files here, or rather, let's make this just a little bit easier here. Let's just include the .cpp files, because maybe that's all we care about. Now we're down to 16. So again, there's different ways to filter and try to find our entry point here. But again, we're going to revisit this tool grep to show some useful tips here. So I just wanted to do that live for a moment. All right, so again, here's the same experiment, grepping around, finding main. Again, if you have colors and these sorts of things in your terminal, that can also make your life a little bit easier. But again, some range of 30 or 37 entry points. And again, here's some other tips on filtering with grep, just looking in CPP files, or maybe you want to see in that specific Objective-C file what the entry point is, and so on and so forth. But grep for this particular thing might not be exactly the right tool. It's definitely going to be helpful, again, giving you a sense of what's going on in your code, finding different main and entry points. But maybe we should actually do, run this program, like I mentioned. Now, an important thing before we run a program is going to be actually to include debugging symbols. So again, this is something, -G, wherever you can append that, or in your CMake, right, to do the equals debug build. And again, basically what debug symbols are going to do is give your program more information. Okay, and this, is somewhat of a trivial thing, but if you have a running system too that maybe you can't shut down or want to practice this skill, there's other ways, and we've linked here to a few resources of loading debug symbols at runtime that might be possible. Again, we're looking at a game which has a clear start and a stop, but if you're running some microservice or something that attaches, again, there's some really cool things you can do with debuggers. Okay, so again, the key thing is to compile, again, with debug symbols and have a debug build for our exploration. Again, this goes back to that, how do I build software? How do I actually build this project so we know what we're doing here?
And maybe just one note on debug symbols. It's often confusing when people think about debug symbols versus a debug build. There's orthogonal features, there's debug symbols, and there's optimization. And you can have optimization with debug symbols. You can have either or both of them. So if you've got something where you're wanting to work on code, but you have to work on the optimized build, you can still add debug symbols to make it easier to debug. It's not necessarily easy, but debug symbols are not necessarily forcing it to be an unoptimized debug build. This is something that can be more complicated when you're working with your company's build system, and it's very difficult to change things. So.
Yeah, and this is very common in a game, right? To have an optimized build and want to be debugging the thing that you'll actually release to your clients. Okay, so I want to do a little bit of just step-by-step debugging here. Just by a show of hands, how many folks have used GDB before? Okay, that's a good chunk of the audience, 80% or so. LLDB, maybe a different debugger. Okay, good chunk. Visual Studio's integrated IDE, or some other IDE integrated in your, or debugger in your IDE. Okay, so this is getting to many folks. But a debugger, is used for finding bugs, but it's also a great tool for, again, code understanding. So let's go ahead and just kind of repeat that first task here. This time using a debugger, which will, directly get us into the entry point here. So let's close or move this source file out of here. Now I'm in my build directory here. Let's make that just a little bit larger for you folks. And I've got my build here that I'm going to execute, and I'm going to go ahead and execute this with GDB here. All right, so we are in here. I see I'm reading in the symbols, so I've done some debug build ahead of time for us here. And the thing that made me love GDB is actually going in the text user interface here, so you can actually see where our program is. And then I can just simply do start, right? And this is going to put a temporary breakpoint on our entry point here. And it looks like I have to download some debug symbols here to figure out how to cache that. But this gets us to our entry point here. So let's move around here just to see. This is our main here, and we can see the file at the top, unix_main.cpp. That's our entry point, okay? And let's kind of just look around here a little bit. Now, of course, I can step through and debug this with commands like next and kind of move through here. So it looks like it's doing some interesting, make sure our arguments are validated here. I'm going to keep hitting enter, which is repeating the next command to step me through. But this is giving me a good view just by looking at my entry point of what happens before the program starts. Okay, maybe loading in some data, some arguments. Where does the actual game start? And then what happens after? So already I can start building some map of before, the beginning, middle, and end, so or so forth to think of the program here. So let's do next here, next, and then I'll do step here and hit enter in a moment to see open ttd_main. Well, that's the actual main that we're interested in, where this game starts. And already just by reading code, we could probably learn this is a nice way to set up your main file, nice and clean. There's not thousands of lines here, but we can redirect to the main. That's probably a good idea. So let's step into this and see what's going on. Okay, I'm in some C++ stuff here. Let's see, span here, next. So right into the argument. One more download here.
Oh, this will be a big one. Unfortunately.
Well, I'll just let it run. That's a good thing we have backup slides here, huh? So, anyways, this is a nice experiment to do. Jump in, see what's going on in main, and we can start to get an idea of what the ultimate control flow is. So let's just run the video and see what's going on here. Again, same experiment, this time actually running the game. But in this particular video, Chris, I'm going to do something just a little bit more useful perhaps here, and I'll pause it here for just a second. What I'm going to do here is, we probably don't always want to dive in from the start every time that we're doing this, right? It's bringing us to the main menu screen. We probably want to dive into the program after something interesting happens, right? Like I create a train or some event happens. So what I'm going to do is attach to a process here while the game's running, and then I can hit Control-C and dive into my debugger and then step through. All right, so I'll let this play through. And what I'm doing is grepping for the process. It's going to be kind of a classic thing that you're going to want to do with a lot of these tools. Figure out what process ID Open Transport Tycoon is running in. Again, I'm going to go into the, I need super user permissions to attach to a process, so sudo. And then I'm going to do this, dive in, probably download some debug symbols. There we go, that was a lot faster. And then I could kind of step through this project here. I could put a breakpoint at main or interesting places. And again, this is finding the main here. But we'll do something a little bit more interesting here in a moment. All right, so here's sort of your GDB cheat sheet if you're not familiar with just diving in, doing next step, finishing to jump out of a function if you don't, again, want to just keep hitting next forever. And again, killing your process, and BT, which prints out the backtrace, or you can just type out backtrace and GDB. Again, these are going to tell you what that call stack was. So you can kind of get an idea of what's going on with your program flow here. Now, we can probably do better here, though.
Yeah, so this is where I'll step in for fairly obvious reasons for those who know undo. So time travel debugging is not just undo, there are various other options for you. RR, GDB's inbuilt feature if you're working on a really tight loop. But fundamentally, we've all been using debuggers, or at least those who put their hands up at one point or another, have used debuggers where you're stepping through things and you get to the point where you should have stopped, but you actually step over and you just get so infuriated. And this isn't just when you're stepping through, just generally when you're trying to debug something and you get to the point where you found something interesting and you want to know, how did I get here? We want to be able to explore. Reverse debugging is a way to be able to do that, and that's what time travel debuggers offer. This is the ability to record the execution while it's happening. So rather than having to go back to the start and come through again and try to get to the same point, we can just step backwards. As I've already mentioned, RR is an open source version which is available for Linux. There's WinDBG on Windows, which is part of the Visual Studio, which allows you to do it there. But if you're working on Linux, I strongly recommend you have a look at what Undo can offer in terms of the tool base there. I know there are a number of users in this room. So reverse debugging allows you to pull a reverse card and actually look at what happened. So I think Mike found some references for sort of very early days. This is right back in GDB 7. This is actually before Undo was even formed. So this is when GDB started introducing the reverse step and reverse next. This is implemented very inefficiently by today's standards, by literally single stepping and making a note of everything that's changed and single stepping and making a note. So it can actually unwind the execution by doing that, but it's very slow. So it's good if you're working in a tight loop, doesn't really scale up to the size of applications that we're talking about today, but that's sort of where we started.
Just curious, how many folks have tried reverse step or reverse next in GDB or some other tools? Okay, I see 3 or 4 hands up. Great.
Okay, yeah. So, from Undo, this is a much more modern feature. We're now running orders of magnitude faster. Basically, the slowdown that we're able to achieve is sort of between, 50% slower to maybe 5 to 10 times slower. If you're multi-threaded, then you can get it can slow down further still, but we have ways for tackling that, and we can help performance tune. But this basically gives you a GDB-like experience in the command line, so you can use the front end while having access to all of these features. So yeah, definitely worth considering. There's a QR code to get access to the free trial if you want there. And we'll have a quick look at this. If you want to learn more, come and see me at the booth. This is not about me pitching Undo to you, but this is just giving you some context of where I come from. But I will give you time to scan that QR code and have a look at the free trial. But yeah, the website is undo.io, so it should be fairly easy for you to find. So let's have a look at what Undo allows us to do. So with reverse debugging, we have the ability to record, and we can see in this example the sort of first capturing and recording. We're using the live record tool, tending to record on symbol, so we're starting at a specific point in the function. We're not recording from the beginning. We're going to start when we get to somewhere interesting, and then running Transport Tycoon Deluxe. And then we can replay that recording in our tool to allow you to start debugging and analyzing it. So this allows you to do the record and replay separately. This can be quite convenient if you want to record remotely or if you want to record things in order to then share and collaborate on that because the recording is portable. So this is an advantage of having that. So here's an example, I think Mike recorded of, was it? No, this one I think is yours, yeah. So this one, I think, right here, if I just make it bigger, this just shows example of using the tool, just sort of allowing you to step forwards and backwards through some basic source code. So with reverse capabilities, you can go backwards to the start of recording, you can step forwards with next, but the advantage of the time travel capability is this being able to go backwards. So you can see we're now stepping backwards, and every time you step backwards, the entire state of the application is unwound to that point. So you can see the heap, the stack, all of the threads, everything they're doing at the point in time. So this allows you to sort of be able to see the history, and not only can you step backwards, you can also run backwards to breakpoints or watch points. So if you've got some data you're curious of where it came from, you can set a watch point and do reverse continue, and it will run backwards and stop at the point that data was last modified. And now running a video has decided to tax your laptop in the way web-based video does these days, unfortunately. So yeah, that's the basics of it. Here's a slightly more detailed demo. There's not a huge amount of time travel in this one, but this is now linking back to this. This is going to be a bit of a eye test for people. Yeah, I'll move the mics a little bit away from the fan so that we can hear us over the fan noise. So yeah, I can do this one. So this one, in this case, we're actually looking at Open Transport Tycoon Deluxe, looking at how we can follow what's going on. If I start this video, we have in the debugger screen, this is the data structure for the train. And you can see I've highlighted the profit for this year. I need to move on now off so that disappears. And we can set a watch point. This is an eye test, but the video is available. So you can set a watch point on the profit for the year. This is the location in the memory for where that data is stored. And then we can resume the execution, and I've unpaused the game, and trains continued and we've stopped. And the reason we stopped is because actually there's running costs for this train. So every day in the game, the running costs get calculated, the profit for the year went down. So here we can add an additional condition to this break watch point. So rather than just stopping any time that value changes, we've now said any time it changes and gets larger than the current value. So this is when does the profit go up. And we can see the train's continued, it's got into the station, it's unloaded. And now we've stopped at the point where the profit for the year went up. So when an interesting event happened, and we can start exploring the code base at that point. So this is one of the ways you can follow data through a code base rather than having to follow the control flow, which often requires you to read, the hundreds of lines, thousands of lines of code and work out what function calls what function. Sometimes it's easier to follow the data and go, well, this is the data I'm interested in. Who touches this data? Where does it get modified? And the watch point, you can just watch that value in data every time it changes, anytime it's accessed. You can do with an access watch point to see how that data is used. And this allows you to find other ways to explore the code base and find what's actually relevant and interesting to the task I've been set. You don't necessarily need to know a code base completely in order to start working on it. Most of us don't get the luxury of 4 years to understand the code base before we're given our first bug to solve. So this is just a quick example of how you can do that. Thanks, Mike. There's a further YouTube link at the bottom. So this was a presentation given in Berlin by the CEO of my company, Greg Law, on basically time travel debugging, how it can work. At the end of that presentation, I actually give like a 15-minute demo of tracking a SQLite bug through the SQLite code base. That's about 300,000 lines of source code. So this is, without any real familiar with the code base, how you can follow the data to find the root cause of an issue there. So that can be quite interesting and just gives more context to how we can do that. But it's not as flashy as Open Transfer Tycoon Deluxe, so we're not going to make you watch it today. Okay, but yeah, there are various things to do, and there are lots of hints and tips, and undo and and Greg Law specifically has put out a lot of content. There's a blog post he does, the GDB watch point, which is about different ways and tips and tricks to use GDB, and I think we've got the link for that later in, as a reference.
Yeah, so Chris, we've done some interesting experiments here, things like using watch points, jumping in, finding our entry points, and all of you folks were taking notes while we were doing this, right? No, just kidding. But that's one of my next points here, right? Keeping a coding journal. I've always kept something, appropriately in your company's wiki or, Google Doc. Here's an example of John Carmack, the programmer from Doom, kept these plan files, right? It is a to-do list of interesting things you found. What structure did you find for that train, for instance? What data were you actually watching, so that you can come back to it later. So again, a little bit of a, soft technical thing here, but keep notes here on the investigations that you're doing here. So how else can we find what's important here, right? So we've found some ways to just dive in from the start to maybe find a structure that's of interest. But another common thing that we'll do often with performance is try to figure out what is sort of the important maybe subsystem in the program. And oftentimes a profiler can help with that. So again, just by a raise of hands, how many folks have used a profiler before? Okay, so a good chunk of folks. If you haven't, Perf is a great one on Linux. And again, there's often ones available for every operating system or in your IDE. But this will identify the hotspots in your code, so where you spend most of your time, or maybe where you're spending no portion of your time, or maybe where something interesting is happening in your program, maybe where there's a lot of variance or a spike or something. But that's the idea here. So again, we can repeat this process. I've got another video here, but basically the idea is you can hop into or launch Transport Tycoon. I'll just let it play briefly here at 2x speed. And basically run perf, and it'll just start recording or sampling events and tell you, again, what's interesting. Where am I spending lots of time? Is it in the main loop? Am I pulling something? Is there some thread or data structure of importance? So again, just to give you an idea of what the major components are of the architecture. So again, same idea of generating a record here. All right, so here I just do some stuff like building some road and profile a little bit to see if I can capture that, and then I could generate a report on what's going on here. Okay, now you get a lot of information here from that perf report, which is of interest, or potentially of interest. But we could probably also do better with, when you have some huge project and actually trying to visualize it. So Valgrind, so it's pronounced Valgrind according to the website, is another sort of tool that we use for often, or at least I was introduced, was for finding memory leaks in code, but it's got a whole suite of tools. And one of the other tools with it is call grind, or maybe call grind, and kcache grind here. But these are tools that will basically take that profile and help you understand, again, the program flow. So what's actually going on in the program. So again, I'll do just a brief demonstration here. Let's see if that debug info downloaded here. Still going. Let's just can that. See you later. This one I've already got set up for us. But basically what I can do here, if I go into my build directory, is I can run Valgrind. It'll generate a profile for me. And then I'll run this tool here, kcache grind here. And it'll take that profile run here, and it gives me some interesting stuff here. So let me just sort of navigate you towards the left side of the screen here. Here are some functions of interest, and on the left column, leftmost column, you can see how much time or how many times I executed this function here. And if you click on these, you get some visualizations. At the top, there's sort of these boxes stacked on top of each other. That's representing the call stack, and the size of the box is representing how much time I spent there. Okay, so bigger might be more important for some reason for that particular profile. But probably of interest is if I click on the call graph or call tree, which is what actually happened during execution, I can scroll through this and get an idea of what functions were called. Again, just a little visualization here. Right, and this is a nice thing that you can just take a snapshot of and put in your coding journal and say, okay, here's what I was looking at. I've identified some interesting function or lack thereof. Again, these visualization tools can often be very helpful. Okay, so let's get out of there. Yeah, question.
So just to repeat the question for anyone who didn't hear, the question is, it's all well and good when you're debugging your code and you've got access to the source, but what happens when you're trying to integrate a third-party library and you're having difficulties getting that to work? Yes, it's certainly difficult if you don't have the source code available to you. Often in the commercial world, if you bought a library, you might be able to have access. If it's an open source library, obviously you can get that separately, but you may not have built it, or it may have just been built by another part of the company. If you can get the source code, do debug symbols, ask for a debug build. Hopefully you can get that. Otherwise, it does get down to much more of a sort of skill understanding how to debug from disassembly, which is not great. One of the nice things about the reverse debugging capability is if you can record all of the interactions with the library, because you've recorded the execution, you can see every API that gets called, what data was passed in, what data was received. That way you can then start comparing that to the API documentation and really see exactly how are you using it. Are you using it correctly? Have you maybe made a mistake in the way you're using it? But this, it does become much more of a challenge when you're working with basically a closed environment where you can't see it. So there are tips on Greg's GDB watchpoint, I think, specifically for debugging without source, but it's definitely a challenge, and ideally, we don't recommend it. For today, we're mostly focusing on stuff where you have got the source code, though. But if you want to talk more, please come and find us, and be happy to talk about that.
Yeah, and we'll give you a few tips here, which actually, so this was, again, just looking at our call graph here that we did. And again, you can search as you find interesting functions and these types of things here. And again, it gives you a view of your source code. And again, you can use this information to feed into your debugger.
Okay, so yeah, the pure scale and software complexity. So we've seen sort of lines of code, and here's the output again for the Open Transport Tycoon Deluxe. But you know, you really want to try and get some idea of what the code flow and how do we make this something that you can actually focus on, and what are the things that you necessarily do need to understand, what are the parts you can ignore. And as with most things, basically if you've got a complex task, break it down to smaller steps. It's impossible to tackle these big things as a whole. Try to break it down to where you can access things and just sort of reduce the scale of what you need to look at. Moving on, and we talk about pure scale, but actually there are some times when you just do need to be looking at lots of different things at once. So in the first instance, you know, we are software developers, we look at the source code, often we'll have to have multiple files open and see. This is actually one of the few places where it's about spending money directly, but get a big screen or multiple screens. The more you can see, the easier it is to understand when things are related. That last line I did check this morning, but you know, this is not a big expense. No company should have any problem giving software developers good screens. This is not a big expense. So petition your managers, ask for it, because the only thing that you physically need from your hardware is to make it easier for you to do your job. You don't need a faster computer to build. Most of the builds are done in the cloud. You don't need a faster computer to run the test suite. Most of that's going to be done remotely. But physical screen can be a huge help in just being able to visualize what's going on. Seeing some of the graphs we saw, that call graph was a huge call graph. If you had a portrait 4K screen, you'd actually be able to see a lot more of what's going on. So this is one of the few areas where, yeah, beg, borrow, steal, get yourself some better hardware. Obviously, if you're an individual coder and you know this is stuff that you're doing as a hobby or your spare time, again, it's still not an outrageous expense, but definitely when you're working, there's no excuse for your manager not to buy you a better screen. As I said, that was just checking this morning on what Dell were charging for a standard coding display. You don't need the latest gaming rig, but you want the pixels and you want the real estate. Obviously, once you've got your screen, you need to be able to display things. So you need good tools, and good window manager if you're working the command line, IDEs as well. Obviously, will allow you to display things and manage your windows around. I think Mike is particularly keen in the working in the command line, so a big fan of Tmux and Vim to manage all of the windows. We're not going to have a Vim Emacs fight today, but there are definitely options. but there are tools, and you want to find ones that work for you. And yes, there are definitely people will advise you and evangelize on different ones. You should definitely look at the options, but what works for you is what matters. So don't necessarily force yourself to use something just because you think this is what I'm supposed to use. Find the one that works and allows you to see the code and visualize and search through the code and find the files you're looking for, when you've got everything set up properly. So it's a question. Yeah, so that's one.
So, another thing that came up at the start of this presentation is we found, 5 HTML files of documentation here. In the actual project, they do have a nice wiki page and stuff. But again, if you're working on a large project and you don't have documentation, you can generate it yourself, right? You can actually run through, and if there are comments, those will get taken in with a tool like Doxygen or DoxyPress or whatever your favorite tool is. And at the least, it'll help you organize some of the code, or at least build a mental model in your head. So again, I have another video. I'm not going to play it right now, but just on generating Doxygen from the source file. And the point of this too is you can often get a layout of the different classes and diagrams. You can get the inheritance structure. So if you find or are investigating some structure of importance, you'll have an idea of, is it inherited or what's the dependency structure? And the other thing that I like too about having this summary of the documentation is it tells me things about the code. Like, they're returning uint32_t, right? So it can look really great during your code review if you also use fixed with types, if that's a convention, if they're returning things like string ID, if they're naming things with, a snake case with lowercase and underscore. So again, conventions you can learn about and often tell you about where is this code coming from. Oh, it's coming from my code because we're returning things in this style, or is it a library?
Yeah, and in general, when you're trying to learn something, it's always good to see the same thing represented in different ways. And Doxygen is exactly doing that. Rather than just looking at the source code, which is raw, the Doxygen has formatted it differently, highlighted different aspects of it. So yeah, all these tools allow you to see different things.
And getting to a question earlier, code you don't own. So again, you can run tools like LDD to see what the shared libraries are, dependency walker on Windows. Again, that probably has OTool or some of these other tools that you can check out. So in this particular example, I picked out a graphics library. And again, we can kind of do the same thing. One other tip for documentation that you generate, or why it's a good idea for libraries you own or don't own, is searching offline documentations a lot faster often. So I recommend tools like ZLDocs or DashDocs to help you search and navigate documentation that you own or don't own. And of course, you can always look at tests and examples. Wait, tests? You wrote tests, right? Everybody wrote tests in their code, hopefully. Oftentimes, if you're lucky enough, you can at least find some smaller bite-sized examples. Going back to what Chris said at the start of this, right? Reducing your scale as small as possible if you're able to, if you have tests. If you don't have tests, maybe that's a great first thing that you can do as a task to start learning Codebase. Now, I have a bunch of notes here that I'm going to go through, you'll see on the slides, but I think there is a world in software visualization. This is something called a software city, which uses a city as a metaphor, where a block is maybe a directory or a namespace and a building as a file. That will help us. We are going to need more tools as we have code that's AI generated, these sorts of things, and understanding what's going on in our code base. Oftentimes you can visualize threads communicating with each other as buildings light up and so on. And there's a bunch of other tools for refactoring and visualizing your code here.
Yeah,
So,
also seeing people displaying performance data as traffic on this as the calls between different functions and different groups.
yep. So there's some other soft advice here on studying design patterns. We're looking at a game here, so finding a smaller game project to get an idea of what does the main game loop typically look like. There's a reference here for a bunch of open source projects here. Chances are you could find one that maybe looks similar to your system, right? Find an open source GitHub project that's 1,000 lines of code trying to do a minimal version of what you're doing. That can be helpful. And of course, our text editors are helping us do various inference and so on. So I'll talk just a little bit about the human factors as we kind of wrap up here. We're getting closer to wrapping up, right? We've talked about control flow, working at scale. And again, the real thing sometimes you have to wrestle with is, the person in front of me, meaning myself, and other humans. And what I'll say about this is oftentimes finding a first good task, if you're just learning a code base, is a great way to learn, right? Being pragmatic, not just saying, oh, here's 10 million lines of code and then going, panic. Where do I start? Right? Find a small task, exactly like Chris showed in the video of recording. What does a train do when it arrives in a station? Or how do I add an extra element to a widget? How do I change some text? How do I change something in a config file, right? Those are examples of good first tasks that direct you a little bit and you learn about a small chunk of the code base. Again, taking a big problem and making it small.
Or even look through the bug tracker and pick a bug to have a go at.
Yep, exactly. So in this case, if you have a Git or GitHub, there might be labels, there might be bug tracker, and you can look, again, maybe if you're lucky, they'll be labeled with small or minor details. This project actually has good first tasks on it. But again, these are things that you can do to get up to speed. And again, if you're a manager, if you're a super senior manager on a project right now, think about creating these labels for your project so your junior engineers can get up to speed here. And again, if you're not assigned a good first task, right, why did we do all that grepping stuff? Oftentimes you can search for words like to do, fix me. I once saw a project that had a bunch of swear words in it, and that was a good hint of like, something's probably broken there. So anyways, these could be good ways to kind of just query around and see, what to do here. So, here's a little to-do note sort of towards the middle. Perhaps we should do this for all the name generators. These types of words or question marks even can be good things to look at. All right. So anyways, fixing warnings, adding things. These are all just kind of tips for good first tasks for trying to get started. And again, use your debuggers, UDB, GDB, RR, etc. For trying these tasks out. Some other human factors here, just worth mentioning, when you're new to a team or if you're a senior team, right, be nice to everybody, right? Meaning, empathy really matters a lot when you're working on a team and again, a large code base where everybody's got to work together, be patient with each other. So it is fine to ask questions to, hopefully have that question. If you're the one doing the asking, bring something to the table, what you tried, where you're looking, what problem you're trying to solve. And if you're getting asked something, come with it, the attitude, if you're a senior engineer, of, oh, maybe this is something we should document better, or yeah, that wasn't clear, or this should be part of our onboard training, again, to get folks up and running. Yeah,
Or
sure.
maybe because now you've told them that these tools exist, ask which tools are already in use. It's a sophisticated question that could also help them target.
Yeah, so the remark was on asking what tools are being used already, what information is being found. That's great. Yeah, so that you have tools or know, yes, we're using Mac, so here's the equivalent of Algorand tool that we can use here.
Yeah, so we have a bonus round now. So AI, I'm sure people are all curious. Does AI solve this problem? No. Okay, that'll be a quick slide. Yes, AI actually really can help. One of the things to remember is that it is nascent, it's changing dramatically. It's definitely changed since the slide was last modified, which was last night at about 2 a.m. But even so, AI is constantly changing. If you are looking for in commercial world, make sure you're using enterprise AI tools. You've got to have the AI licensed appropriately to your organization, and your organization has to approve you sharing code and sharing insights. This is a big thing, be aware of it. But it can definitely help summarize what the code's doing. It will search through the code base far faster than you ever will to find the paths and threads through and help explain the code. Be aware, though, that it's still a pattern matching tool fundamentally. If it sees something it thinks it understands, it will be very convinced that it understands what's going on and won't always question and digging for the truth. This is often referred to as hallucinating in the AI today. So be careful. As I said at the very end, trust but verify. So you can trust it, but make sure you check. There are a number of tools out there. So SourceGraph is allowing you to sort of see context of what's going on. ChatDBG is an open source integration to try and integrate ChatGPT with GDB for managing debuggers. We saw last night the lightning talk that Rashmi gave, where we'd integrated UDB with Claude Code to basically be able to say, tell me why this happened. And the AI was able to start exploring and driving the tool to explore. That is currently a prototype. It's not, but we expect to be releasing products and to our customers later this year to be able to do that sort of integration. But yeah, basically remember, AI gets distracted. It thinks it knows what it's doing. It can be very convincing when you're looking at a code base you don't know and it says, oh, this is why this happened. It sounds authoritative. It's not. It's just good at being convincing. So do double check. But with those caveats, it can be very powerful. So recently, in order to explore some things, I actually looked at a MySQL issue, and I think I might actually go on. No, I'll stop this video while I'm talking. But this is just going to be repeating some of the stuff we've already seen, just in Visual Studio Code. So you can see there's an SQL query. It's calling some specific functions. I start looking at those functions, searching through the source code. So this, much like the stuff we've seen earlier with GDB and grep, this is in a sort of more IDE type world. We can search through the code, we can find sort of a relevant function, set breakpoints, and continue to that, and then start exploring how it happened and explore the context. But the goal here, I was trying to tackle a particularly large application. We'll see on the next slide quite how large, but this is a real world application. This is where I took an open bug ticket, used recording to try and track and trace and find my way through the code base, and then used AI to help explain it to me. And we tried that and the first time, and unfortunately AI failed. So if I go next, well, am I not presenting? Ah, there we are. So yeah, so the first time that AI failed to get it, it was hyper confident and even convinced me that it had some ideas, and it just wasn't. So I said, why is this not working? And it goes away for 5 minutes and so comes back and says, I know what it is. It's definitely this. Here's a patch that fixes it. And it got it completely wrong. There's actually an article linked at the bottom that was published yesterday, going into a lot more detail about that. As you can see from the count lines of code, there's 2.4 million lines of C++ files. There's another 900,000 lines of C++ header files. This is a very sizable project, but the open source projects are there. So by using these tools, it actually enabled me to tackle it. I got to a root cause of the bug. I actually submitted notes back to it. This bug had been open for like 16 months. And as soon as I submitted my findings, it said, oh yeah, we fixed that already. We just didn't know it related to this. There was another fix that fixed the bug with a newer release. But yeah, there's more of a story there if you want to have a look into it and see what's going on.
All right, so we're gonna wrap up as we're nearing time here. We've got a bunch of resources. Again, the slides will be posted, so feel free to check out these sort of case studies. But overall, we've looked at some tools for wrestling with control flow, data flow, software scale, and again, remembering that we're humans at the end of the day who are working together in this large code base. So take some of these tools, these findings. Maybe this is an idea of a tech talk that you can bring back to your company, if you're doing weekly talks of what's actually going on in our code base, and you can have somebody senior or junior kind of step through. The other advice, the last advice that I'll give is the thing that helped me most when I was a junior engineer was asking one of the senior engineers very nicely, hey, can I just shadow you for 15 minutes? I'll get you coffee or whatever is appropriate. And they would always oblige and basically let me do that. And I would always learn a new tool, new way to investigate the code, and be able to ask some of those silly questions when the space was created to do that. So learn your tools, and don't be afraid to work with folks.
Yep. Just have to second everything you just said there.
Yep. So thank you for your time. We're going to hang around and we'll take questions if we have a minute. Otherwise.